Now we're going to begin talking about stoichiometry. Stoichiometry is the calculation of the quantities of reactants and products involved in a chemical reaction. Let's consider this general equation here where the lowercase letters indicate the coefficients and the uppercase letters are representations for generic formulas. If I have the grams of molecule A, I can convert to moles of molecule A using the molar mass of molecule A. But not only can I convert from grams to moles, but I can also convert from moles of molecule A to moles of molecule B. And that's where the coefficients come into play. If I have the moles of A, I can use my conversion factor where the coefficient for moles of B is on top and the coefficient of moles of A is on the bottom, and that's going to allow me to convert to moles of B. We're going to be using this mole to mole conversion as stoichiometry, and that's going to allow us to start with the grams of a reactant and get grams of a product out. So let's go ahead and try this. If we look at the Haber process, which is how we convert nitrogen into ammonia, we see that the equation is set up so that one equivalent of nitrogen is reacted with 3 equivalents of hydrogen to give 2 equivalents of ammonia. Well, if we have 2 moles of N2, how many moles of H2 would we need to get the reaction to work? Well, we have our conversion factor here. For every 1 mole of N2 from our equation, it takes 3 moles of H2 in order to use it up. So we can set up our conversion factor as either 3 moles of H2 over 1 mole of N2 or 1 mole of N2 over 3 moles of H2. Well, since we want to have our desired answer be H2, we're going to use the first setup. Therefore, when we take 2 moles of N2 and multiply by the quantity 3 moles of H2 divided by 1 mole of N2, we're going to end up getting 6 moles of H2. So for every 2 moles of N2 that we have, we need to use up 6 moles of H2 in order to get the reaction to go to completion. Not only can we use mole conversions to find the moles of the other reactant that we would need, but we can also use it to find the moles of the product that we would make. So let's try another example using the same Haber equation. Here, if I take 3 moles of N2, how many moles of NH3 can I make? Well, now we're going to have to set up a different conversion factor. According to our equation, for every 1 mole of N2, you're going to make 2 moles of NH3. So I can set up my conversion factor in one of 2 ways, and I'm going to choose to set it up with the one on the left, the 2 moles of NH3 over 1 mole of N2. So when I do my conversion, I'm going to start with 3 moles of N2 multiplied by my conversion factor, 2 moles of NH3 divided by 1 mole of N2, and that's going to give me 6 moles of NH3. So just doing mole conversions with our coefficients in our equation is very straightforward, and these are very easy ways to figure out how much of the other product we would make or how much of the other reactant we would need in order to use up a reactant from the mole quantities. Unfortunately though, we're going to have an overall goal for stoichiometry, and that's going to be converting from the grams of A to the grams of B given the equation above. Well, we can't go there in one step. We have to go there in stepwise manner. The first thing we have to do is convert to moles of A from grams of A by using the molar mass of A. Then we can convert from moles of A to moles of B using our molar conversion from our coefficients in our equation. And we always want to have the moles of our desired unit on top and the moles of our given unit on the bottom. Once we're at moles of B, to get to grams of B, all we have to do is use the molar mass of B and multiply to get the grams. So that's the overall goal that we want to accomplish using stoichiometry. And in the next video, we're going to get into this in more depth and detail and actually go through gram to mole, mole to gram conversions in a lot of detail. So for right now, just focus on using the coefficients to do mole to mole conversions of a reactant to another reactant or reactant to a product.